Hey guys, welcome back to the channel. Today we're going to be looking at a confusing topic, which is actually very simple, in Class 10 Physics, Chapter 12 in your science textbook, resistance versus resistivity. So, everyone thinks that these two quantities are the same, but the truth is they're not. Although they're based on the same principle, which is Ohm's law, they vary distinctly in terms of their units, their measurement, and their applicability in physics. So let's look into each of these aspects in depth. First, we'll look at resistance. So resistance is a quantity which measures the ability of a conductor or a wire to oppose the flow of current. So we know that current is the flow of charges. More specifically, it's the flow of protons. So when protons are flowing across a conductor or a circuit, there is also a tool or a device called a resistor. The symbol, as you can see on the screen, is almost looking like three upside down V's. And that's a resistor, so it opposes the flow of current. And depending on the quality of the resistor, it could oppose all the protons or a few protons. So in this resistor, it's opposing 3 of the protons. It's not allowing them to pass. But 1 proton was allowed to pass. So if the current is flowing from left to right, the resistor is blocking or opposing 3 protons of charges from crossing. The SI unit, or International System of Units, that are used to measure resistance are ohms, and it's named after the scientist George Simon Ohm, who also formulated the Ohm's law. How to calculate resistance? So Ohm's law provides a formula, which is V is equal to IR, and V is the voltage or the potential difference, I is the current, and R is the resistance. So V is equal to IR, and if we divide both sides by I, we get a new formula where it's in terms of resistance. So resistance is equal to V by I, or potential difference divided by current. Can resistance vary? Yes, it's not a constant quantity. Depending on the length of the wire, the thickness of the wire, and the material of the wire, resistance can increase or decrease. The resistance is directly proportional to the length of the wire, meaning that if the length increases, then resistance also increases. It's inversely proportional to the area of cross-section, meaning that if the area of cross-section increases, resistance decreases. And also the material of the wire. Is it a good conductor, bad conductor, or a semiconductor? Good conductors have low resistance, and insulators or bad conductors have high resistance, and semiconductors have resistance somewhere in between. So ultimately the point here is that resistance is not a constant value. Now let's move on to resistivity. The key distinct factor that differentiates resistivity and resistance is that resistivity is a characteristic property of a material which determines its resistance per unit of length. So earlier we mentioned that resistance is a quantity which measures the ability of a conductor to oppose current. But here in resistivity, it's a characteristic property. And properties cannot change. For example, in these two people right here, their skin color and hair color are physical properties that cannot change. They cannot be influenced by length, environment, or any other factors. Similarly, any physical properties such as the hardness, brittleness, malleability, ductility of metals, they cannot change easily. And similarly, resistivity is one of those properties that cannot change or vary. The SI unit is ohm meter because resistivity measures the characteristic property in which the ability to oppose current per unit of length and per unit of area. So suppose we have 3 meters of a nichrome wire. Nichrome is an alloy of nickel, chromium, and manganese. And so if we have 3 meters and its resistance for this 3 meters is 6 ohms, then the resistivity is 6 ohms divided by 3 meters. And this is just a hypothetical situation. It's not the actual resistivity of nichrome. We'll look into that later. But just for example, it measures the resistance per unit of length. So for 3 meters, nichrome has a specific resistance, and for 6 meters has specific resistance. But this resistance remains constant. Can resistivity vary? As we mentioned and discussed, no, it can't. It will remain constant regardless of the environment and size of the material. So how is resistivity denoted? Resistivity is demarcated or symbolized by the Greek letter rho, which almost looks like a P. So the symbol is rho. For resistance, the symbol is R, the letter R, capital. What's the formula to calculate resistivity? So the formula of rho is resistance multiplied by area divided by the length of the wire. So as I mentioned earlier, resistivity is the characteristic property which determines the resistance per unit of length and area of cross-section. So we're combining all three of these quantities, resistance, area, and the length of the wire, and creating one simple equation. So how can we derive this equation? We know that resistance is directly proportional to length and inversely proportional to area of cross-section. And if we combine these two equations, we also get a constant, which is rho, and that's how you get this equation. Now let's look at a quick resistivity table. This table is provided in your textbook, and you don't have to memorize these values whatsoever, but just for simplification and understanding, I want to break this down. So we have conductors, alloys, and insulators, and we're given the resistivity value in the SI unit ohm meters. So we can see here that the exponent value for conductors is in the negatives, and that is also true for the alloys. But for the glass, hard rubber, ebonite, all of these insulators have an exponent value with the positive numbers, 10 to the power of 10, 10 to the power of 13. So this indicates that the metals or conductors have a low resistivity, and the alloys and insulators have a higher resistivity, which means that alloys and insulators are bad conductors and good insulators, and conductors are good at conducting electricity, and their resistance is also low. So in this table, I've summarized the essence of this video: resistance versus resistivity. So resistance is a quantity, whereas resistivity is a characteristic or a property. The former can vary, while the latter remains constant. Resistance is denoted by R, and resistivity is denoted by P. The SI unit of resistance is ohms, while the SI unit of resistivity is ohm meter. And the formula of resistance is equal to potential difference divided by current, and the formula of resistivity is rho is equal to resistance times area of cross-section divided by length of conductor. So now let's look at a few potential board exam questions. Number 1. State the differences between resistance and resistivity. This question was actually on my school pre-board exam. And to answer that, we can just look back at our table here. Next question. The resistivity of a given material is X. If the area of cross-section is doubled, what will be the new resistivity? So this is a trick question at its finest, because it says the resistivity, not resistance. And we know that resistivity remains constant regardless of the area, length, and material. So the new resistivity will also be X, because it will not be influenced even if the area of cross-section is doubled. Next question. The resistance, not resistivity, of a wire is X. During an experiment, the length is doubled and the area of the wire is halved. What is the new resistance of the wire? So we know that resistance is directly proportional to the length of the wire. So if length is doubled, resistance will also double. So then the new resistance will be 2x. But it also says that the area of the wire is halved. And resistance is inversely proportional to area of wire. So if area increases, resistance decreases. And if the area decreases, resistance increases. So now, after doubling the wire, our resistance was 2x. And if we halve or reduce the area of the wire by a scale factor of 0.5, then we would get double the resistance. So our new resistance would be 4x. The answer is 4x. We'll also get several numerical based questions, which are simple as long as you remember the formulas. So here we have two resistors of resistance 2 ohms each are connected in parallel. The voltage source has a potential difference of 20 volts. Find the total current. So this question is pertaining to resistance only. There's no factor of resistivity involved, which is a relief because that means there's no aspect of trickery in the question. So the first thing we highlight is that the resistors are connected in parallel, meaning that they're top to bottom. They're not connected in a straight line. So our first step is to calculate the combined resistance or equivalent resistance of the two resistors combined. And a resistor is essentially a device that produces a resistance, or a device that has the ability to oppose charges. So first, always write the given and to find values. So we're given the resistance of two resistors, 2 ohms each. And we're also given the voltage or potential difference, which is 20 volts. And we have to find the current. So step 1, find the equivalent resistance. We know that if they're connected in parallel, the formula is 1 by resistance in parallel is equal to 1 by R1 plus 1 by R2. So if we substitute our values, we get 1 by 2 plus 1 by 2. 1 by Rp is 1. And the value of the equivalent resistance is the reciprocal of this. So the total resistance of the combined resistors is 1 ohm. So now we have our total resistance and we have the potential difference. According to Ohm's law, V is equal to IR and I is equal to V by R. So I is equal to 20 by 1. 20 divided by 1 is simple. The answer is 20. So current is 20 amperes. And that's the solution to this question. At first glance, it might appear lengthy and it could invoke fear. But if we break down the question, it's very simple to solve. That concludes this video on resistance versus resistivity. This topic is confusing because everyone thinks both of them are the same. But as long as you're able to differentiate between the two using the properties that I mentioned in the video, this topic should be no sweat whatsoever. So as always, thank you so much for watching. I hope you enjoyed this learning experience, and until the next one, this is Ch.12 signing off. Peace.